We would like to show that the following functions are harmonic. Part A, we have a polynomial of degree 2 in the variables x and y, and this will be harmonic because the square terms have opposite signs. And then we have the function e to the x cosine y, and we have the logarithm, the natural logarithm of x squared plus y squared. So to show that a function is harmonic, we have to show that the Laplacian of the function is equal to 0, and the Laplacian of the function is the second derivative with respect to x plus the second derivative with respect to y. So the pure partial derivatives of the second order. So for part A, f sub x of xy is 2x plus, we treat the y as a constant, so the derivative of a constant times x is the constant. So the derivative with respect to x here is 4y minus y squared is a constant with respect to x, so this is 0. 5x, the derivative with respect to x is 5, and the derivative of 6y and 2, they're both 0. So f sub x is 2x plus 4y plus 5. So f sub xx is 2 plus 0 plus 0, so it's just 2. And I suspect f sub yy will be negative 2, and then the Laplacian will be 0, and the function is harmonic. Let's see, f sub y, 0 plus 4x minus 2y, 0, negative 6, 0. And f sub yy, 0, negative 2, 0. So negative 2. And we see then that the Laplacian of f, which again is f sub xx plus f sub yy, is 2 plus negative 2, and that's 0 for all xy, and that means that f is harmonic function. Okay, b. Here's b, f sub x, the derivative with respect to x. This is a constant, cosine y is a constant, and the derivative of e to the x is itself. So f sub x is e to the x cosine y, and f sub xx is again e to the x cosine y. Now f sub y, in f sub y, e to the x is a constant, and the derivative of cosine is negative sine. So we get negative e to the x sine y, and then the second derivative with respect to y, the negative e to the x is a constant, and the derivative of sine is cosine, so negative e to the x cosine y. And when we add these, we get 0, and so this function is harmonic as well. And the last one, the log of x squared plus y squared, f sub x. We use the chain rule. We have a function of x inside of the natural logarithm. So the derivative of the outside is 1 over the inside. And then the derivative of the inside with respect to x is 2x. And we'll just put that up on the top here. So f sub x is 2x over x squared plus y squared. Then f sub xx will need the quotient rule. The quotient rule says the derivative of u over v is the bottom times the derivative of the top minus the reverse divided by the bottom squared. So we have x squared plus y squared times 2 minus 2x times the derivative of the bottom, and we're doing our derivative with respect to x, so that is 2x plus 0, and then divided by the bottom squared, x squared plus y squared squared. And this numerator will simplify. We will get 2x squared plus 2y squared minus 4x squared. So we're going to get 2y squared, and And then we had plus 2x squared and minus 4x squared, so that's going to be minus 2x squared. And then you can verify that the second derivative with respect to y will be the exact same thing with the x and y switched. And then when you add them, you'll get 0. And so we have a harmonic function here in part C as well. Let's just look at that. F sub y, we have 1 over x squared plus y squared plus times the derivative with respect to y, which is 2y. And then we use the quotient rule. And you see that we're getting the exact same thing, except for with the x's and the y's switched. And this is 2x squared minus 4y squared. 2x squared plus 2y squared minus 4y squared. So altogether, 2x squared minus 2y squared. And of course, when we add these, the numerators are opposites, so we will get cancellation, and the Laplacian of f is 0, and f is again harmonic. So those are some harmonic functions.